now we start discussing Newton's laws of motion for fluid flow. Of course, you are very familiar with Newton's laws of motion. They are very famous. We started learning them from the school times, and they are applied to a rigid body or in mechanics. But here we will be applying the same laws and the equations thereof to fluid flow situations and not to rigid body. So there will be some variation, and some of the things that do not take place when we are looking at rigid body motion. So Newton's law, of course, they are familiar to just about everyone, even anybody who has gone to a secondary school, he knows about Newton's laws. So, but mind it that, of course, we are mentioning them here, but here we are focusing them for fluid flow situation, analysis of fluid flow situation, and how when the external forces are applied to fluid flow, how do they behave with Newton's laws of motion. It's so important that those fluids that follow Newton's laws, that work under the Newton's laws of motion, they are classified as Newtonian fluids. And there are certain fluids that do not follow Newton's laws. They are known as non-Newtonian fluids. So on. And therefore, so the objective here is to identify the various kinds of forces and moments that act on a control volume. And of course, control volume that we consider in a fluid flow. Use control volume analysis to determine the forces associated with the fluid flow. And use control volume analysis to determine the moments caused by fluid flow and torque that is transmitted. Now, remember, there are three ways of determining fluid flow, predicting fluid flow, and analyzing fluid flow. One is the differential method. Differential method is very accurate, but it results in differential equations, in the formation of differential equation, and many a times the differential equations are easy to solve, but a large number of times the differential equations are not solvable by analytical methodologies that we know. So we need complicated computer-aided fluid dynamics in which we used computer finite element methods to solve those differential equations. That is a very tedious job, and therefore that method creates a difficulty in that sense. But many equations are solvable, then there is no problem. But at other places, we have problem there. The other method, second method, is by doing experiments. If we do experiments and try to find out the results of a fluid flow, the action of forces on the fluid flow, and so on, that method is very accurate and precise, because you have seen it by doing experiment, how does it behave. You know the result. And so therefore its accuracy is indeed very good. But many a times, this also has a problem. Number one, experimental work is very difficult. It's not easy. And it's not easy to develop a model that represents the fluid flow in an appropriate manner, in a suitable manner. The second thing is that doing experiments is a very expensive method. So we use experiments to analyze and discuss fluid flow, but Not always, because when it becomes too tedious, when it becomes very expensive, time consuming, and so on, then therefore that method also has its plus points as well as negative points. The other option that we have is by considering a control volume in space in a fluid motion. And that method is reasonably good enough to predict the fluid flow behavior, the action of forces that are taking place, and so on. So therefore, considering control volume method is also a good option, and that is what we use in many places. So that is why we mention that use control volume analysis to determine the forces that are associated with fluid flow, and use control volume analysis to determine the moments caused by fluid flow and the torque that is associated with it, the torque that is developed. So these are the basic objectives that why we are considering Newtonian's laws of motion for fluids.